Welcome to the Biotechnology, a Regional Perspective panel. I am your moderator, Hillary Bradburn. I work at the MassHire Metro North Workforce Board. And today we are able to deliver this panel in partnership with the STEM Network, Fog Pharma, and Synopsys. So I'm going to introduce our two wonderful panelists. So our first panelist is Adrian Fong. He is a senior cloud engineer at Fog Pharma. So he's fairly new to the Fog Pharma team, but he has held the roles of senior cloud engineer, systems engineer, and others in his 6 years in foundation medicine. So though Adrian did not have a direct path to cloud engineering, he is very happy he landed there. So welcome, Adrian. Thank you for joining us. Our next panelist is Catherine Calabro. She has been a research and development engineer at Synopsys for 8 years. Previously, she held the role of research assistant at both Boston University and Pennsylvania State University. Her specialties include stochastic, I hope I said that correctly, computer modeling, optical spectroscopy. No, I said that wrong for sure, but you can correct me, Catherine. Okay. And biomedical optics, to name a few. Welcome, Catherine. Thank you so much for joining, and thank you for your patience as I butchered all of those words.
No worries.
And as I mentioned before, I'm your moderator. I am the new Senior Director of Workforce Initiatives at the MassHire Metro North Workforce Board. I joined the team last week. This is my second week. Prior to that, I was working in adult education at a nonprofit in Boston, providing ESOL classes and skills training classes to refugees and immigrants. So I'm going to dive right in. I have a list of questions, and so you will both get a chance to respond to all of our questions. So the first question, I'm going to start with Catherine. When did you know you wanted the career you have today?
It's a good question. It's a tough question too, because the career I have today, I didn't know existed when I, was coming up through the ranks. I knew that I wanted to do something with science and something with math since I was in high school. It was something that I was drawn to. In particular, most of my day-to-day work now is programming, so computer science type work. And I think I knew that that was something that I was really passionate about and could do like as a career. I was very lucky at my high school to have, for juniors and seniors, a computer science course. It wasn't, it was like every other day for like a semester or something, but even that, I remember just being really fascinated with how I could, program and like give instructions to the computer to have it do what I wanted to. And then if something didn't go right, I could go back and see, just the logic interplay of all of that was just so interesting. And when it came time to do homework at the end of the night, and computer science homework was always the one that I was like, all right, if I do everything else, then I get to do that one. And it always excited me. It was the first time in school that an assignment was like fun to the point I was looking forward to it and was really absorbed in it while I was working on it. And I think that's probably how I knew that that was gonna have something to do with my career going forward.
Yeah, that's great. That's wonderful that your school was able to offer those classes. Thank you. So Adrian, I'll ask you the same question. When did you know that you wanted the career you have today?
I still don't know, to be honest. The role that I'm in now, cloud engineering is a very new term, honestly. Just in the past, just the way technology has evolved is where this role kind of appeared, with everyone kind of moving to the cloud as the popular term right now. So starting off, I was actually back in high school planning to be an architect. and did a lot of classes in drafting and, structural engineering and things like that. But then going into college, I went to Boston Architectural College, and right around 2007, 2008, 2009, that was just a huge downfall in the whole architectural workforce. Everyone was getting laid off, and part of school was to actually get a co-op, and that was just impossible at the time. So as a second passion of mine in technology, just from playing video games and things like that, I got a job at the Apple Store and just talking to people about MacBooks and iPods and things like that. And then that kind of went into doing technical support, working at the Genius Bar at the Apple Store. And then that led to desktop support at various companies, and then evolving into systems engineering, network engineering, and then now cloud. So just kind of shifting from that architecture. There's still a lot that I learned from that I still apply every day in terms of just a lot of logical thinking. Engineering is engineering. You're just changing what you're engineering, I guess. So yeah, this role is still evolving, and as technology progresses, I'm very excited to see where we go in the next 5 to 10 years.
Thank you. Yeah, that's quite a journey. So our next question, I'll take it back to you, Catherine. What were your influences in childhood, and what influences you today?
I would have to say that growing up, my parents were a big influence to me. They both definitely fostered a love of science and kind of critical thinking in me. My dad worked as, a chemist. My mom did a little bit of that and then was a math teacher. And so seeing that day to day and having the reinforcement that even when this is hard, it's okay that math and science is hard, but it's more dependent on your perseverance. And if you enjoy it, it's worthwhile, pushing through the stuff that's hard. So that was probably, again, I was really lucky to have role models to show me that kind of career path can be possible, and kind of the mindset that goes into a technical career path.
Great. Thank you so much. So Adrian, the same question for you. What were your influences in childhood and today?
A lot of it's pretty much the same. Coming from my parents. My parents are immigrants, so they moved here from China. So just kind of seeing how in terms of hard work was really instilled in me growing up. Because seeing my parents, they didn't come here getting any prestigious jobs or anything like that. And then just kind of seeing how they work their way, just working hard. So whether it's something you're passionate about, or if it's just daily duties, just if you're putting in the effort, you're going to be able to get to where you want to be. And so throughout my career, and then just throughout life, it's not necessarily knowing this is what I want to do, but whatever you try, if you really put your full effort into trying it, and then knowing that it's not for you, that's okay. But then at least you know that you gave it your all, and then there's no regret. So everything that I've tried, I just made sure I gave it my best, and then, okay, that's not for me, now to try something else.
Yeah, that's great. Thank you so much. So our next question, what are the trends and outlook for AI in general and in your company? And Adrian, I'm going to have you go first this time.
Sure. AI is definitely a new space. We are actually kind of dabbling in that at the moment. So even at my last company at Foundation, we did genomic sequencing. So our dabble in AI was really to kind of speed up the process, because a lot of sequencing afterwards, it took a lot of manpower for curators to kind of take a look and look for alterations and things like that. And with the introduction of using AI, having a computer, having a model be able to learn and be able to identify these things rather than having to have a human do it, really kind of helps speed up the process. So how many samples we can process and things like that. And then even here at FOG, that's something we're looking at now. We're using AI to do 3D modeling of peptides and things like that, and then having it recognize a lot of the information so that it frees up the chemists and the biologists to kind of do more exploratory things.
Great, thank you so much. So Catherine, I'll ask you now, what are the trends and outlook for AI in general and in your company?
Yeah, AI is obviously a really big buzzword, and it's definitely going to shape our industry particularly. So we do software modeling. The product that I help work on is a product that other engineers use to design products that interact with light, so lamps and various things. And so our perspective on the AI is we're interested in knowing how those engineers and how those customers want to use our product in a way that helps them make their designs faster and makes their products faster. And to the extent that we can incorporate AI algorithms and support into our product, that's where the software and its power being able to be leveraged to help in those enhancements of the design process. So we don't have a lot of that now, but the speed of computing, and we do simulations which are very, very time intensive. But even since I started working at this job and to now, the advancements of GPUs and just cloud farms, cloud computing has come so far that you can start thinking about not just getting the simulation done fast, but then using these AI type things to take it from just raw ray tracing to how can we help the engineers design something faster using information and algorithms we can gather and enhance that with.
Thank you. So now I want to ask, and I'll start again with you, Adrian, what are the trends and outlook for biotech in general and within your company?
Well, in terms of biotech space, a lot of the trend right now is really utilizing tech to speed up the science side of things. Even here at FOG, we're really trying to leverage when I first came in here, a lot of our compute was physically on premise, and we spent the past year doing a lot of migration into leveraging Amazon Web Services to host a lot of our pipelines to be able, so then that way we can scale. So in terms of for biotechs and smaller companies, it really gives the flexibility for companies to grow exponentially. And rather than being limited by, oh, we have to add more servers and things like that, it's just a matter of clicking buttons and writing code to scale out infrastructure as opposed to having to build it physically. So that's kind of a trend right now is, especially in the tech space within biotech, is really automation and building out infrastructure using code rather than clicking things and manually physically putting pieces of hardware into data centers.
Mm-hmm. Great, thank you. So Catherine, now I'll ask you that question. What are the trends and outlook for biotech in general and within your company?
Yeah, I have to agree with Adrian in general. The other thing I love about biotech is that it's not necessarily one field. Like you have mechanical engineering, or you have architecture, where it's a very specific field with specific skill sets that you use. And biotech is this great thing, biomedical, and all this engineering. Bioengineering is great because it uses all sorts of different technology skills and fields, but with commonality of the same end goal of trying to improve things for healthcare or other biological related things. So it's not the skill set that's the commonality in the industry, it's more the applications that's the commonality. And with that, you there's just so much more opportunity to utilize all different kinds of technology from across all different kinds of sectors. For us in particular, my background and the research that I've done in the past was for biomedical spectroscopy, so like cancer diagnostics using light. And now that I'm working for Synopsys, which is a software company, and we do like modeling, now we are looking at utilizing some of those same simulation and design design knowledge that was used for cancer diagnostics, and now we're using it to help design smartwatches and wearables and other things, or cosmetics. So it's expanding the knowledge of understanding of using this simulation knowledge that was used for one particular area of biology, and now expanding it, and so you can use it for other areas, more commercial areas, maybe not necessarily always medical. And so for us, as simulations get faster and you can do more things, and the understanding of how light propagates within, especially the skin, there's going to be a lot more opportunities to be able to develop and model accurately devices that interact with the human body in all sorts of ways.
Great, thank you so much. So I guess I have Biotech to thank for my amazing Apple Watch and all the stuff I can do with it. So our next question is, what opportunities do you see for young people in STEM that maybe they don't see for themselves? And Catherine, I'll ask you this question first.
Yeah, I think my biggest advice to young people who might not see themselves in STEM is that STEM is really broad, and that what is STEM within the classroom of math and memorizing chemistry, equations and all that stuff, that is STEM, and that is really important. And there are areas where that's important, but STEM is a lot more than that. I would say I think Adrian mentioned it before, the key aspect of STEM is really problem solving and critical thinking. And if you're not great at the quadratic equation, that's not as important as having a critical mind of thinking, all right, if I want to do this experiment, or I want to try this new approach, or this new design, what are the steps that I need to go through, from planning to execution to analysis of the results to reiterating it. And you'll see that same kind of sequence of thought that is important to be trained in all areas, whether you're working in a lab doing experiments, whether you're programming, doing computer work. And let's be honest, computers are going to be a huge component of tech and biotech as we go forward. So it's not always, I'm in biotech, but I was awful working in a wet lab in grad school. They did not want me in there, but I can still be in biotech. I can still contribute in ways that I can use my skills for.
Yeah, thank you so much. And Adrian, what would you say in terms of what opportunities young people could take advantage of if they don't necessarily see themselves in STEM?
Yeah, and just piggybacking off of that last statement, in terms of the skills are very transferable, like critical thinking and logical thinking, whether you want to be in biotech or in tech or biology or chemistry or anything that you typically would think falls underneath that. That skill set is transferable to any other job and career. So I would just, my advice would be to put yourself in a most advantaged state as possible. So just having all of these things, you may not need to know what you want to do yet, but no one does know. I mean, if you're 17, 18, to decide what you're going to be for the rest of your life is a very hard decision there. But at least if you're taking the steps to gain those skill sets, then when you finally do figure out what you want to do, you don't have to start from scratch, in a sense.
Yeah, thank you so much.
Just one thing I wanted to just add on, because it reminded me of an advisor in grad school who would say, he's like, people don't come to grad school to learn specific knowledge. I mean, you do, but the most important thing you learn when you come to grad school is to learn how to think. And it's that learning how to think and learning, how to find out the information you don't know that is far more important than any specific information that you would ever be tested on a test.
Mm-hmm. Yeah, that was totally my experience in grad school too. I mean, I went the social science route, political science, but definitely the biggest takeaway was just how to think and how to research things for myself. So our next question is a little bit more fun. So what do you love about your job and what makes you want to go into work every day? Adrian, I'll start with you.
Definitely the tech. I mean, genuinely, I like technology even outside of work. So just, it's one of those things of having the opportunity to be able to play around and dabble with the latest technology that's out there. That definitely is something that I find, I'm very grateful for the fact that I can come into work and play with new toys. So, something's new out there, whether it's a brand new piece of equipment for technology, for like laptops or things like that, or enterprise equipment. It's like, hey, can we buy one of those? And then just get to play with it. It's pretty cool. So that definitely is something that gets me going into work every day.
Mm-hmm. Yeah, sounds fun. Catherine, what about you?
Yeah, I think some of the same things that originally drew me to like programming and software development is still what keeps me like engaged to keep coming back. There might be some, difficult algorithm that I've been working on that, even after the workday, it'll kind of be in the back of my mind thinking about it. And then, I'll wake up and like, oh, wait, what if I try that? Maybe that would work. And kind of the reward you get from solving those hard problems and the reward you get from like seeing the progress of a project move like through the stages. And it is, validating and rewarding to see that happen. I think another part that doesn't get talked about a lot, but also I really like working with my coworkers, and a job aside from the actual tasks that you need to do and things you need to learn, it does have, a big component is working with coworkers and working with other, people on teams. And if you have good relationships with them, and, that makes a job all the more enjoyable. So it's not the most important part of a job, but I find, from talking to others that it makes a big difference of your enthusiasm to come in at the beginning of the day and, work with them and chat with them. You get to know them on a personal level. So it's still part.
Great. So as you may know, the theme for this STEM week is See Yourself in STEM. So we're talking about ways to get people of color and women more involved in the STEM field. So my next question for both of you is, what do you think we can do to create more diversity in biotech? And Adrian, I'll start with you.
Definitely having the opportunities at a younger age, like things like this, for example, and just getting people excited to work in these fields is kind of a definitely beneficial. Like, growing up, biotech wasn't even really a thing that I knew about or heard about. So just having that exposure and putting it out there that this is something that you could go into. I think just starting from there and in earlier education, it would make a big change there.
Mm-hmm. Great, thank you. And Catherine, what about you?
Yeah, exposure is really important, and not necessarily always exposure to specific science, knowledge. I volunteer with the local optical society, and we'll go and show optics demos to, science or in classrooms or whatnot. And I think the most important thing of that exercise is not having them necessarily learn the information we're telling them about, what's a diffraction grating and like how, what's additive color versus subtractive color, but what's more important is the exposure to understanding, you know, in broad strokes, that there are these different kinds of fields. I actually remember in high school, I wasn't even aware of the term engineering. So just that awareness is, you know, I was, I knew science, I knew math, and then I got close to college and I had a guidance counselor be like, oh, maybe you think about engineering. I was like, I don't drive trains. What are you talking about? So just the fundamental kind of exposure to opportunities that are out there, knowing what's out there. And particularly for people who, you know, that's why I love the theme of this week, this year, is see yourself, because it is very difficult. I was lucky again to have role models and parents, and I could see a direct pathway that my life could take following the path. But you know, just like if your parents are maybe actors or something, then you see that path, but I couldn't see that path myself. So being exposed to as many different people in their career paths, I think, is important, and seeing, you know, people who look like you and have the same background to you is, you can't underestimate that as a powerful motivator.
Definitely. Thank you so much. So Heather, do we have any questions in the chat?
Right now, I'm not seeing any questions in the chat. Thanks for checking, Hillary. But I do have some questions, if I might ask.
Take it away, yeah.
Sure. So in terms, and these questions are in terms of the student's perspective. So as maybe persons of color, different abilities, maybe first generation students, et cetera, who the theme See Yourself in STEM are trying to reach. Some folks may not have that connection to see themselves in STEM, as you were talking about, Catherine. They may not have the parents who are involved in STEM, or they may not have, like, just in general, a network involved in STEM. Like, what advice would you give them to start on their road to STEM? What's a first thing you think they should do to get involved?
I take that. I think probably the first thing is even just having the motivation to want to go out and learn more about it. That's honestly probably the biggest hurdle. That's why I think some of the STEM networks that are around, like I'm involved with the Metro West STEM network, and some of those organizations, which are collectives of schools and industry and other partners, that's what it's really all about, is instilling that first spark of interest to try to show them and expose them to people that they can see themselves in. And I think that's one of, a critical piece of the puzzle. But for those who are already like, yeah, I think I really am interested in STEM and I want to move forward, a great place to start is your teachers, a science teacher at school, see what kind of information they have. I had a science teacher who recommended a class or a course, a summer camp, like for 2 weeks at the local community college where I was growing up. And she's like, I heard about it. I thought, since you've told me you're really interested, maybe you might be interested in doing that. And I wouldn't have known about it otherwise. So that was a good relationship to kind of foster that. And then, speaking of technology, we're lucky to live in a time where you can literally find anything out on the internet that you want to. Sometimes, you have to be careful. Obviously, not everything is true on the internet, but YouTube is for as much flack as it gets. It's a fantastic resource to learn things sometimes. I dabble in like home repairs as like a hobby on the side, and the things that I've been able to learn how to do on YouTube, having no training and being able to be like, I wonder how I patched the drywall in my house. I'll go ask YouTube. But there's lots of great channels out there, and you can find recommendations of, National Geographic has resources, and there are, you know, independent people who explain hard concepts in a way that's easy to understand, that sometimes like use as resources to like understand. So thankfully there's a lot of stuff out there that you can get access to without a huge barrier to entry.
Yeah, that was what I was gonna say, was that the internet is basically the equalizer now. Back in the day, you know, you needed a college degree, you had to go to a 4-year college, get a master's, but now the internet makes all that education accessible. I mean, even strictly from the technology speaking, just from my own experience, most of the things that you need nowadays in the workforce in technology isn't something that you can actually learn in school anyways, just because how quickly technology is evolving and growing. That information isn't going to be in a curriculum, but that is something that could potentially be in a curriculum online. So things like Code Academy and Udemy, Cloud Guru, all of these online learning centers for where you can learn about Google Cloud, Amazon, Microsoft Azure, all of these services. That's the only way to keep up. Even for me daily at work, I'm constantly online on some either a YouTube video on how something was set up or taking some other course online. But these are all things that are available to anybody. So the barrier entry is low. And then also I want to say that opportunity is everywhere. So it may not be something that you think is related, but jump at every opportunity that comes up. Like even for me, my entry into technology was working at a retail Apple store. So it wasn't exactly like, oh, I want to be in STEM and I want to work in biotech, so I need to go find an internship at some biotech. Like I worked at a retail shop selling iPods for 2 years. And that kind of went from there. So really just whatever opportunity comes up, just take it, because you never know where it might lead you to.
Thanks for that. And speaking of opportunities, are there internship opportunities for high school students in your companies?
We don't have anything for high school students, but we do work pretty closely with Northeastern. From a college perspective, we do have quite a few co-ops from various universities as well. We have quite a few people cycling through in all different departments, whether it's on the biology, chemistry side, or even in technology. We had a couple interns doing some development work in computer science.
Yeah, same for our company. I'm not aware of internship opportunities for high schoolers, but I know, you know, we're thinking this summer of recruiting a co-op student from local community colleges if we can, to do some measurement stuff that we need done. So yeah, there's not a great consolidated place to find out all those opportunities. It's kind of, yeah. But if you look for them, again, college level stuff, I wish there were more opportunities for high school.
Oh, so do we. We love to help place our high school students into cool STEM internship opportunities. So I know you spoke before about, you know, the internet being the great equalizer and so many courses available to anyone who's interested in any area of your fields. I was wondering, in terms of the student who wants to go to college, you know, is on their way to college, they're on that path. What type of culture would you recommend they look for to be able to get the best education they can, to get the most out of their education to lead them to either fields?
I don't think I quite
so far.
Sorry. So in other words, what tips would you give them to be able to find a really good university to study either, you know, optics, biotech, or AI, or, you know, any other aspect of your job that you're involved in?
I feel like the college landscape has not only changed significantly since I was in that you know, my life, but also I envision it changing significantly, especially after the pandemic. So I don't know how much specific information, but in broad strokes, I think any place that you go, it's about taking, you know, I've said this several times already, taking, you know, taking advantage of the opportunities that are there for you. So the people that I noticed that, you know, really made the most of their college careers were the ones who weren't shy about going to like office hours and talking to the professors, getting to know the, you know, getting help from the TAs, really interacting and becoming part of it, not just here's the assignment, I'll do the assignment, I'll do the test, here's my grade, but involving yourself in as much as you can within the culture of whatever college or community college or wherever you are. It is what you make of it. And so the more involved you are and the more going and, you know, take the initiative to go above and beyond, that's really what's going to make the difference.
Yeah, in terms of the schools, I mean, when I was picking colleges or like, if you wanted to get into computers, computer science was really the only degree that was out there that was related to computers. But nowadays, the whole technology field is you can actually pick something that you're interested in that without just a broad degree of computer science or technology. And so if going to college, like finding the school that offers a curriculum in these specific fields that you're interested in, that would be how I would go about it in terms of picking a school. But then also in terms of learning, I mean, college gives you that kind of structured learning, but if you are someone like, actually for me personally, I actually prefer a more unstructured type of learning where I can just pick and choose what I want to learn. And I have found that online classes and just online education services rather than a particular school gives me that kind of flexibility of more unstructured learning. So I don't think college is for everybody. So for me personally, I actually prefer the method of learning on my own. But that also has a caveat of you need to be driven to learn that way. Whereas I found with school, sometimes for some people, it helps when someone just tells you, okay, this is what the next thing is, and this is what the next thing is. That works for people too. So it's really finding what is your best way of learning, and then leaning into that. And sometimes it's going to require trying multiple ways before you figure out which one works for you. So if it is going maybe to a community college, because that's what I did. I went to Bunker Hill Community College, did 2 years of that, got my associates, and then I learned that, hey, this is not really how I like to learn. So I'm going to try a different route. But I wouldn't have known that unless I actually did it.
Mm-hmm. Yep, thanks for that. And last question. You know, we hear a lot about how lucrative STEM careers are, and not that anyone is driven solely by the income across these careers, but students are always curious as to salaries. Can you speak to the range of salaries in the different careers you're in? Not necessarily your own salary, we don't want to tap into that, but just an idea for the students so they can know what it would look like.
A tricky question. Yeah, so being in the STEM field obviously is going to afford you the opportunities to have a career with a salary that's comfortable. I will say that I was surprised that after going through college and high school and then talking to friends who chose different career paths, it's not always going to be the top. Like as a scientist, working in a tech field now, I'm definitely not at the top of the pile of friends. There's lots of different ways to find success in the world, and just because you're in science and tech isn't the golden ticket that being having the best grades in school does not necessarily directly relate to your success in the real world in a career. And I say that just because that shouldn't hold anyone back from doing what they really want to do and what they love to do. In terms of salaries, though, I think that it's a comfortable salary in the tech industry where you don't have to worry. It's not an hourly rate. Most of them are salaried. Out of college, you're probably going to be looking, gosh, it's been so long since I've been newly out of college, but in like the $50,000 range, depending on the degree. If you go to graduate school, then you kind of take a step back, and then you're going to be working. The nice thing about graduate school is you do get paid if you're in the sciences, though. So that's a nice thing to know. So you get paid to work in the lab and teach classes. And so then you're looking at like a $20,000 to $30,000 a year stipend while you're getting your degree, which could be anywhere from like 2 to 6, 7 years. And then once you get out, then you'll be back up, to the post-college range again, but comfortable. Say.
Yeah, speaking from a technology side of things, it's fortunate that the landscape is very heavily leaning on technology at the moment. So that kind of affords higher salaries too, because the jobs are so in demand. So in the field of like cloud engineering and software engineering in general, so software developers and things like that, it's actually pretty good at the moment, the landscape, because of just the demand, and especially with COVID, and now like people are really utilizing technologies for remote work. You kind of get a bump there from just the economy. So you can look from, just something simple like just being service desk and desktop support, helping people with their laptop issues and things like that. You're probably looking at like 60, 70, around that range. And then the thing with technology though is because there's so many, like you can find a niche, and if that's the case, the salaries can be pretty lucrative there. If you're working on a particular piece of technology that only a small subset of people know, all of a sudden you're in very high demand. But yeah, cloud engineering in general right now, it's a very wide range, going from entry level to senior to architect and things like that. So as you can be from like 80, 90, all the way up to hundreds, 200. It's a very broad range. And then the thing with technology too is there's technology in every space. So if you're working in finance versus biotech versus marketing, like everybody needs help in technology, right? So it also depends on the industry you're in. I've found personally that the finance space, tends to pay a little bit more, as opposed to working in like a smaller company in biotech or a larger company in biotech. It's kind of all over the place.
Yeah, and just as a somewhat related note, salary-wise, sometimes you push yourself and like not jump from job to job, but if you are always evaluating kind of what your next career step is, moving between positions and moving between companies or fields is a good way to help ratchet that up.
Thanks so much.
Yeah, so I think that's all the questions we have for today. One final thing, if either of you have resources that you could share with us that instructors could share with their students, that would be wonderful. Feel free to drop it in the chat, or if you would like to email us later, we can send it out too. I just want to thank you both so much for your time this morning. This has been very informative, and yeah, I hope more students can see themselves in STEM.
Thanks so much.
Yeah, thanks so much for having us.